Okay, section 11.6 is just reminding you how to find least common denominators. So you recall to add or subtract fractions or rational expressions with different denominators, you have to rewrite them with a common denominator. Well, first you must find the least common denominator, the LCD, which is the lowest number of which the involved denominators are factors. To find the LCD, factor each denominator. The LCD should include each factor the greatest number of times it appears in any one of the factorizations. So for example here, numerically here, if we're looking at the numbers 18 and 24, and I wanted you to find the LCD of 18 and 24, you do the prime factorization tree of 18 and 24, which they've done. They've got the 2 times 3 times 3 and the 2 times 2 times 2 times 3. So they factored everything. In order to find the LCD, first of all, you're going to look at the factors. Well, the factors that they have is 2 and 3. But you want to find out which one lists the most. Well, for 2, this one has 3. So that's why they chose to put that one in the LCD. And looking at the factor 3, which one of these has the most 3's? Well, this one has 2 3's, which is why they put that there. And then you multiply straight across and you get 72, which is your LCD. And it works the same way with algebraic. If you were given two polynomials, which we've got here, we have this polynomial and this polynomial, you factor them, okay, which they've done on the right-hand side. And then to find the LCD, you're going to take one of each type of factor and you're going to list it the greatest number of times that it may appear. Well, so here we have x minus 1 and x minus 1, and it's only listed one time, so they put that there. Then they have an x minus 4 and an x plus 5. So notice how we ended up using all three. These here were only used once, right? It's just the greatest number. And so that is then your LCD. So it works nicely. If you have two fractions here, you have 1/18 and you have 1/24. If I can. All right. And so notice here that we're still using the 18 and the 24. The denominators is 18 and 24 on these fractions. We're not adding or subtracting at this point. We're just trying to find a least common denominator and rewrite them so that they have a common denominator. So what you would do then, if you're looking at 18, all right, 18 had 2 3's, and it had 1 2, 1 2. So what is left here is this, the 2 times 2, which is 4. So that's why I'm taking 4 times 18. Or another way to think about it is you say, well, this is 72, so 72 divided by our number that we're talking about, 18, would give you 4. So there's two different ways that you can find out that you're going to be multiplying 4 on the top and 4 on the bottom right here. It depends on how you're looking at it, all right? Now, let's look at the 24, all right? 24 is the same way. Sorry, my erasing doesn't, it's like I have to touch it just right just to get it, you know? All right, so now we're looking at the 24. So we're going to look at 24 and compare it to our LCD. Well, the LCD, it has the 2. It has one of the 3's. What it doesn't have is the second 3. So that's why they ended up multiplying this fraction times 3 times 3. Or another way to do it is you can say here's the LCD divide it by 24, and you would end up with 3. And then we're multiplying straight across, all right? So now we get 1 times 4 is 4, 18 times 4 is 72, 1 times 3 is 3, and 24 times 3 is 72. So we've now rewritten the two fractions with a common denominator. And like I said, this is not new to you. You just haven't done it algebraically yet. Can't talk tonight. So here they've given you some fractions. They say rewrite the following fractions with common denominators. So let's look at the first two. And you might even stop the video and try it yourself if you want. Since we're in class, I'm going to go ahead and keep going. So we've got to get a common denominator. So I'm going to look at 8 and 12, and I'm going to do the prime factorization. 8 is 2 times 2 times 2, and 12 is 2 times 2 times 3, right? And so we have the factors of 2 and 3. So here is 1, 2, 3. So the greatest number here is 3. So you're going to use this 3 times. That's one way that you could look at it. And then, of course, then you have the 3. All right. But what they were doing is they said, okay, well, they have, what are the factors they have? They have 2 and 3. So in this case, this one has 3 3s, and this one has 3 1s. And so that's how they came up with this right here. So our LCD then is, or our common denominator is going to be 24 when we get done. So 8 had 3 2s, but not a 3. So that's why we multiplied this one times 3 times 3. This 12 here, all right, the 12 has 2 2s and 1 3. It's missing a 2 from the LCD, so that's why we multiplied by 2 here, and then of course multiply straight across. You get the 9 24ths and the 10 24ths. Okay, now you can't just multiply the bottom by 3. You have to multiply everything by 1, and 3 over 3 is 1. Otherwise, you've changed the value. So same thing when we have algebraically. Here we have 5y and 3ay for our denominators. So we're going to factor them. 5y is 5 times 5, right? 5 times y. 3ay is 3 times a times y. So we have 5 once, 3 once, we have a once, and then we have the y once. Okay, so that's how they came up with this to be your LCD. We multiply straight across and we get 15ay. So that's going to be our common denominator. So here we have 5 and a y on this one. On this bottom one, we have 5y. So what is missing is a 3 and an a. Excuse me. 3 and an a. All right, and then this one has 3ay. What's missing is the 5, so we multiplied by 5. And that's going to give us what we need on top. And this is going to be 3, it should be 3ax. All right, and then on top is 20. So now we've rewritten the two fractions here. Okay, it says rewrite the following fractions with a common denominator. All right, well now we've got polynomials. So the first thing we're going to do is we're going to factor them so we can figure out what the LCD is. So if I factor the first denominator, I get x plus 3 times x plus 2. All right, so I'm going to let that represent the polynomial x squared plus 5x plus 6. And the second denominator, we have x squared minus x minus 6. I'm going to factor it. And I'm going to let the x plus 2, x minus 3 represent that polynomial there. Now I'm ready to figure out the LCD. Well, the LCD is here we have an x plus 3, and then we have the x plus 2. It's only listed once, one time, and then we have the x minus 3. So that is our LCD. We're going to rewrite these with common factors. So let's look at the first one. The first one I'm going to rewrite. All right. So this first one is this one right here. And so notice that this has an x plus 3 and an x plus 2. An x plus 3 and x plus 2. So what is missing is this x minus 3. So that's why I'm going to put an x minus 3 on the bottom, because we'd already determined that's our LCD, but I also have to put it on the top, all right, to make this fraction equivalent. Now let's look at the second fraction. The second fraction here, this is x plus 2, x minus 3, right? X plus 2, x minus 3. What's missing in the LCD is this x plus 3. So notice that that's why we put the x plus 3 and the x plus 3 on top. And so we've now rewritten those two fractions. And that's all they're asking you to do at this time, is just to rewrite the fractions so they have a common denominator. That's that simple. All right. Let's look at another one. Here they're giving you 3. You might want to try this one on your own, but they've just got 3 fractions. They want you to write a common denominator for each one. So looking at the first fraction, the denominator is y squared minus 1. We're going to factor that to be, because it's a difference of squares, x plus 1, x minus 1. All right, so we're going to let that represent that. Then this one here doesn't factor, and this one doesn't factor. It's their prime. Now we're going to figure out our LCD. Well, our LCD in this one is we have just one y plus x and one y minus y in each one of them. So this would be our LCD. I'm going to take the first fraction, I'm going to rewrite it. Notice it's going to stay the same. This here is the same thing, nothing changed, because we already had that LCD. But now let's look at the second fraction. The y plus the y plus 1. Well, this has a y plus 1, all right, here, so it's missing the y minus 1, which is why we multiplied everything by y minus 1. All right, so that's the second fraction. And then let's take a look at the last fraction, the 3y minus 1. All right, well, here they have the y minus 1, y minus 1, so what is missing is the y plus 1, so that's why they have multiplied this by y plus 1, y plus 1. So those 3 fractions now have common denominators. Nothing has changed in them. All right? And so that's all you're doing in this section, is they're just giving you some fractions and they're asking you to find a common denominator. And that's it.